In which of the following arrangements the sequence is not strictly according to the property written against it? Now this is a question from periodic properties of elements. Now see here, CO2, this is the increasing oxidizing power. Increasing oxidizing power means the ability to get itself reduced. The ability to get itself reduced means the ability to take up electrons. Right? Now, see what all oxides are there, to which group they belong. That is carbon, silicon, tin and lead. They belong to group 4. The maximum valency shown by this group is +4. But the stability of the +4 oxidation state decreases down the group. Do you know why? You must be knowing. The stability of +4 oxidation state decreases down the group. Right? Why? This is because of the inert pair effect. This you must be knowing, right? So, which will have more oxidizing power? If I arrange the elements in the group, how I'll arrange? It will be carbon, silicon, germanium, tin and lead. So the stability of +4 oxidation state decreases. So which will have more oxidizing power? Lead oxide, then tin oxide. In lead oxide, PbO2. What is the oxidation state of lead here? The oxidation state is Pb4, +4. Likewise, tin oxide, the oxidation state is +4. Silicon dioxide, these are all dioxides, right? +4 and CO2, +4. So which will have more tendency to go to +2 state? Lead. Likewise, tin. Right? So they are arranged in their oxidizing power, increasing oxidizing power. So this is the correct one. What are we asked? It is not. Do emphasize on this word not. Right? So this is according to the property written there. Now the next is HF, HCl, HBr, HI, increasing acid strength. According to this, the most acidic is HI. Is it correct? It is HF less than HCl, less than HBr and less than HI. So students, they belong to group 7. And what are the elements of group 7? Fluorine, chlorine, bromine, iodine and astatine. What happens down the group? The size increases. Right? Now, the size increases. Now, when the size is increasing, the bond length between them will increase. Right? As the result of which, what will happen? The bond strength will decrease. Okay? So, they will easily lose their H as H plus ion. So, which will be the strongest acid here? HI, then HBr, then HCl, then HF. The strongest would be HI. Right? So, what will be our answer? So, this second one is also correct. Now we have got the third option, that is the increasing basic strength. Now what it is? What is the basic strength? What do you mean by basic strength? A base has a tendency to lose electrons, right? Now base, if I talk of Lewis base has what? It is a tendency to lose electrons or to donate electrons. Lewis bases, the electron donors are called as bases and electron acceptors are called as what? Acids. Now these elements which are given are nitrogen, phosphorus, arsenic, antimony and bismuth. Now if I go down the group, what happens? The size increases. Size of the atom increases. Right? Now there is NH3. Right, and there is a pyramid above. There is a, not pyramid, I'll say that there is one loop over here. There are lone pair of electrons, right? Now students, this lone pair of electron, these donate. Right? Now if I move from top to bottom, what happens? The size of nitrogen is very, very less. The size of phosphorus is more than that. Arsenic is more than that. Antimony is more than that. And bismuth is more than that. So what happens? The lone pair of electrons, there is high density of electrons on nitrogen in NH3, right? So it can easily donate its lone pair of electron, whereas when we are moving from top to bottom, what is happening? The size is increasing. The density of electrons on these particular central atom will decrease. So the tendency to lose electrons will decrease. So let's check up with the question. What is it? NH3 is less basic than PH3, then ASH3, then SBH3. The order should have been reversed. That is, your SBH3, your NH3 should be more basic than PH3, should be more basic than ASH3, and it should be more basic than SPH3. Because of the small size of nitrogen, the electron density is very high on the central atom and it can easily donate or lose its electrons. Got my point? So what is the correct answer over here? Which is not. Remember that. So this is the right answer according to this question. Which option would be correct? C. Now let's take up the fourth also. Boron is less than carbon, is less than oxygen, is less than nitrogen, increasing first ionization enthalpy. Are they correct? Now students, if I am moving from left to right in the periodic table, what happens? The size decreases. Now if the size decreases, more energy will be required to remove the valence electrons. Right? Because the effective nuclear charge also increases. So whose ionization energy would be maximum over here? Nitrogen. There is one more factor affecting the ionization energy, that is the half-filled or full-filled orbitals. The half-filled or full-filled orbitals are highly stable. So boron has got less ionization enthalpy than carbon, then oxygen and then nitrogen. So this option is also correct.